Working with rational exponents is like working with radicals. Here is the rule. b to the power of 1 over n is equal to, if we are taking the nth root of the base. For example, b to the power of 1 over 2 is equal to the square root, because we can just put the 2 there, but it is just implied whenever we write like this that it's going to be the square root. Another example, b to the power of 1/3, that will be the cube root. And you can take any root. For example, b 1 over 50. Same way. This is the 50th root. Now, what if the rational exponent has a numerator that is not 1, as we saw there? Well, the rule is like this. b to the power of m over n is equal to, you take the root, and then you keep it to the power of m. Or you can also write it out like this. b first the power of m, and then take the root. The same thing. Here's an example with numbers. b power 2 over 3 can be written as the third, so cube root, and then we're going to square that. You can also write it like this. b squared, and then take the cube root. Another example with numbers, 5 to the power of 8 over 7. It does not matter that the numerator is bigger than the denominator here. This is going to be equal to, let's take the root, this one goes on the bottom, and then the power going at the top, or you can write it like this. Using the two possible notations is useful because once we need to calculate the final answer, one version may be faster to compute than the other. If you are not plugging in everything into the calculator right away, something may be easier to compute on paper or in your head. When working with rational exponents, it's important to remember radical rules. For example, I'm going to write this one down. Odd roots can have negative bases, but even roots can't. They can, but then even roots can't have negative bases. We can take a look at an example to see why that is. If we are going to take the cube root of negative 8, we can get an answer which is negative 2, because the opposite of that would be negative 2 to the power of 3, and then we multiply it negative 2 3 times, so we get here a negative times a negative, which gives us a positive, and then this negative gets brought down, and then a positive times a negative is a negative, so we do get a negative 8. But something like this, let's say square root, which is just the same thing as writing like this, this actually has no real solutions. Because 2 is an even number, so you would have your negatives all cancel out. You can't create something that will make this a negative 4.